Imagine a world where car drives themselves, security cameras recognize faces instantly, and machines understand images better than ever before. This is not science fiction, this is computer vision. As you can see, computer vision is everywhere, from autonomous vehicles detecting objects on the road to AI powered facial recognition systems straight out of movies. But how do computers actually see an image? In this video, we'll break down the basics. What is computer vision? How does a computer interpret an image? And what's the difference between grayscale and color images? By the end of this video, you will have a solid foundation in this exciting AI field. And if you haven't subscribed to my channel yet, please do subscribe to my channel so that you do not miss out anything. So let's begin. So, what is computer vision? It is basically a subfield of AI. It includes processing, analyzing, understanding the visual content. What is this visual content? It could be images taken one at a time, or it could be multiple images streaming one after the other in a series. We will discuss more on that, but for now, let's take a pause. What is computer vision? It is basically a visual. Now, what happens? It first processes the image, then it analyzes the image, and then it understands the image. How is this happening? First step is the image processing. So there is an array or matrix of image which is pre-processed, and then this pre-processed image is sent to signal processing. So there are edges and boundaries in an image are being identified, and then the shape and the object is being filtered out, and then comes the applied math part, actually the algorithmic side of it, that is image classification, image recognition, object detection, etc. We will come to that in more detail in the upcoming videos of this series. So in this sequence, the first and the most important component is the image. So what computer actually sees an image like? So an image is a set of pixels according to the computer, which is the building block of an image. So if you look at this, this is an array kind of a matrix. So it's having some height, it is having some width. So suppose this is having height of 28 and this is having width of 28. Each box or each square denotes a pixel. So it is formed with multiple pixels. So an image is nothing but it is a set of pixels. Okay. So in this case, if there are 28 as the height and 28 as the width, so there will be 784 pixels in it. Now image can be represented in two ways. One is the grayscale image and another is the color image. So if you consider only this image, which has only two dimensions, so this will be a grayscale image. Each pixel is a scalar value between 0 and 255. Okay, so it can have any number between 0 and 255. Now what does 0 means and what is 255 means and what the values between these means? So in grayscale, if the value is 0, then this denotes the black, the darkest black color. Okay, and if the value is 255, then it is the white color. Okay, or there is no color in it. So here, if it is say 255, so this will be denoted as white, and if it is 0, that means this whole area will be shaded with a very dark black color, and if it is anywhere in between, it will be black, but it will be depending on the intensity of the number. So The lesser the number, the more darker the color is. Now considering the color, we'll go to the color image. So normally it is represented in RGB format, where R represents red, G represents green, and B represents blue. So this is the RGB format. But there are other format as well, which is HSV, CSMY, but this is the normally represented pattern, that is RGB. Now this is actually additive color spaces. Additive means there are going to be 3 channels in it. So you see there is one channel which is red, another channel which is green, and the third channel is blue. Now for a corresponding pixel of these channels, the values of red, green and blue will be added to form another color. Now that color will be represented as the color of that pixel. So that is why it is known as the additive color spaces. Okay, here also, just like grayscale image, each pixel will have a value between 0 to 255, but it will be for that particular color only. In grayscale it was black, but here it will be based on the channel. So if this is the channel, the first is the R, which is red, then green, then blue. So red will have 0 to 255, then green will have 0 to 255, blue will have anything between 0 to 255, including both the values. Okay, so pixels are represented by a list of these 3 values. Now 255 here means the full color. So if it is 255 red, that means it is full red color. This whole will be the darkest full red color. And if it is 0, that means it is white. Okay, now we have come to the end of this video. In this video of the series of computer vision, we equipped ourselves with the basics of computer vision. We saw what is computer vision, which is nothing but a subfield of AI. We also saw how the computer sees an image. It sees in the form of pixel, where each pixel is represented by a number. We also saw that there are 2 very important types of images, grayscale and color images, which are normally used in the computer vision applications. In the next video, we are going to see what is convolution neural network and how it is better than multi-level perceptron. So I'll give you a glimpse. Convolutional neural network has basically 2 components. One is the convolution, another is pooling. In convolution, we have kernels, we have strides, and we have padding. So we will discuss each one of them in detail. Trust me, if you have understood convolution neural network, you have already surpassed the halfway in understanding the foundation of computer vision. I hope you guys like this video. Please do subscribe to my channel if you haven't done it yet. Until next time, keep exploring and keep pushing the limits of AI. Bye bye.